Imagine a young Earth, a world still hot from its own formation, glowing with primordial heat. This was our planet about 4.5 billion years ago. It was not alone. Hurtling through the cosmic darkness was another world, a protoplanet we call Theia. It was roughly the size of Mars, on a collision course with destiny. The two worlds were locked in a gravitational dance that could only end in one way. A cataclysm of unimaginable scale was about to unfold, an event that would forever change our world and create the brilliant companion we see in our night sky. This was not a gentle merger. It was a planetary impact of epic proportions. The collision was violent beyond human comprehension. Theia slammed into our nascent Earth, not head-on, but at a glancing angle. The impact vaporized vast portions of both worlds, sending a colossal plume of molten rock and superheated gas blasting into space. Think of it as the ultimate cosmic splash. In an instant, trillions of tons of Earth's mantle and the shattered remains of Theia were ejected into orbit. This was not just debris, it was the seed of a new world. A magnificent glowing ring of incandescent material began to encircle our wounded planet, a fiery halo against the blackness of space. This ring of fire was not destined to last. Gravity, the great sculptor of the cosmos, immediately went to work. The countless particles of rock and dust within the ring began to pull on each other. Tiny clumps formed, then grew larger as they swept up more material. These protoplanetary chunks collided and merged, gathering mass and momentum. Over a surprisingly short amount of time, perhaps only a few decades or maybe a century, these pieces coalesced. A single dominant body emerged, sweeping its orbit clean of the remaining debris. A new sphere took shape, a glowing ball of molten rock, born from the fiery embrace of two worlds. Our moon was born. Hot, bright, and much closer to Earth than it is today, it would have filled our ancient sky. This newborn satellite was a seething ocean of magma, a liquid world glowing with its own internal heat. Its gravitational pull was immense, raising colossal tides on Earth's own molten surface. The two bodies were now locked together in a gravitational partnership, a relationship that began in violence but would evolve into a stabilizing force for our planet. The debris had cleared, the collision was over, and a new chapter in our solar system's history had just begun, with a brand new moon hanging in the sky. For millions of years, the moon remained a hellish landscape. Its surface was a global ocean of magma, a brilliant, churning sphere of liquid rock. As this fiery ocean slowly began to cool from the outside in, lighter materials, like the mineral plagioclase, feldspar, crystallized and floated to the top. They formed a thin, primordial crust, a fragile skin on a still molten world. This early crust was pale and bright, creating the lighter-colored highlands we can still see today with a telescope. But beneath this thin shell, the moon's interior remained a violent, superheated furnace, a powerful engine of change waiting to erupt. The young moon's story was far from over. The heat trapped deep within its core needed to escape. Around 4 billion years ago, this internal pressure found its release. Magma, rich in iron and titanium, pushed its way up through cracks in the newly formed crust. It erupted onto the surface not in towering volcanoes like those on Earth, but in vast, silent floods of basaltic lava. These were not explosions, they were effusions. Rivers of dark molten rock flowed for hundreds of kilometers, pouring into the lowest lying areas, the giant impact basins that had already been carved by early asteroid strikes. These titanic lava flows spread out, filling the vast craters and basins to create smooth dark plains. When early astronomers like Galileo looked at the moon through their first telescopes, they mistook these dark patches for oceans and seas. They gave them romantic Latin names, like Mare Imbrium, the Sea of Rains, and Mare Tranquillitatis, the Sea of Tranquility. These are not seas of water, but ancient seas of solidified rock. The dark basaltic lava absorbed more light than the pale highlands, creating the distinct man-in-the-moon patterns that have captured human imagination for millennia. This volcanic era lasted for nearly 1 billion years. The last of the major lava flows likely ceased about 3 billion years ago as the moon's small core finally cooled and solidified. Its internal engine shut down. With no more volcanic activity to resurface it and no atmosphere to cause erosion, the moon became a geologically quiet world. Its face was now set, a mosaic of bright ancient highlands and dark younger Maria. The moon we know today was taking shape, a silent testament to its fiery volcanic youth, a history written in light and shadow across its surface. Even as the moon's volcanic heart was cooling, its surface was under constant assault from above. This period, known as the Late Heavy Bombardment, was a time when the inner solar system was a cosmic shooting gallery. asteroids and comets, leftover debris from the formation of the planets, rained down upon the Moon and Earth. With no atmosphere to burn up these projectiles, every impactor, large or small, struck the lunar surface with catastrophic force. Each collision blasted out a circular crater, pulverizing the rock and leaving a permanent scar. The Moon became a celestial punching bag, its face a record of this ancient violence. The impacts ranged in size from tiny micrometeorites to colossal asteroids hundreds of kilometers across. The largest collisions created immense multi-ringed basins, such as the South Pole Aitken Basin, one of the largest known impact craters in the entire solar system. More recent, and therefore more visible, impacts created the spectacular rayed craters we see today. Craters like Tycho and Copernicus were formed by impacts that hurled bright streams of ejected material across the lunar surface. These brilliant rays, visible even from Earth, are like cosmic splash marks, frozen in time and untouched by wind or water for millions of years. While the Moon's surface was being reshaped, a subtle but powerful gravitational dance with Earth was taking place. When the Moon first formed, it was much closer to Earth and spun much faster. Earth's powerful gravity pulled on the Moon, creating a tidal bulge in its rocky body, just as the Moon creates tides in our oceans. This gravitational drag acted like a brake, gradually slowing the Moon's rotation over billions of years. Eventually, the Moon's spin slowed down so much that its rotation period perfectly matched its orbital period around Earth. This phenomenon is known as tidal locking or synchronous rotation. Because of this gravitational lock, the Moon now presents the same face to us at all times. We only ever see one side, the near side. The far side, with its different terrain and fewer maria, remained a complete mystery to humanity until the Soviet Union's Luna 3 probe photographed it in 1959. This cosmic lockstep is a fundamental aspect of the Earth-Moon relationship. It means that while the Moon orbits our planet, it is not just a companion, but a partner in a gravitational waltz that has lasted for eons. Its scarred face forever turned towards us in a steady, silent gaze. For all of human history, the Moon has been our constant celestial companion. It was the first calendar, its predictable phases from new to full, allowing ancient cultures to track the passage of months and seasons. It was a source of wonder, myth, and divinity. Civilizations across the globe worshipped lunar gods and goddesses, weaving the Moon into their creation stories and spiritual beliefs. Its ethereal light governed the night, inspiring poets, artists, and dreamers. The Moon was not just a rock in the sky. It was a fundamental part of the human experience, a shared beacon that connected everyone who looked up into the night. This ancient reverence eventually gave way to scientific curiosity. The invention of the telescope transformed the Moon from a mystical orb into a tangible world, a place with mountains, valleys, and seas. This new perspective ignited a new dream, to one day travel there. That dream propelled centuries of scientific and technological advancement, culminating in the space race of the 20th century. The Moon became the ultimate destination, a symbol of human ingenuity and our unyielding drive to explore the unknown. It was a challenge that pushed us to the very limits of our capabilities. On July 20th, 1969, that dream became reality. The words, "That's one small step for a man, one giant leap for mankind," echoed from the Sea of Tranquility back to a captivated Earth. The Apollo 11 mission was more than a technological triumph. It was a profound moment for our species. For the first time, we had walked upon another world. The footprints, left by Neil Armstrong and Buzz Aldrin in the lunar dust, are a powerful symbol of what we can achieve when we combine our curiosity with courage and determination. The Moon was no longer just an object of wonder. It was a part of our extended home. Today, our relationship with the Moon continues to evolve. We now know its crucial role in making Earth a habitable world. Its gravity stabilizes our planet's axial tilt, preventing wild climate swings and giving us predictable seasons. It drives the ocean tides, which may have played a vital role in the early evolution of life. The Moon is not just a beautiful satellite. It is a vital partner in our planet's life story. From its violent birth in a cosmic collision to its role as a launch pad for our future in space, the Moon remains a powerful reminder of our place in the cosmos and the endless frontier that awaits.